Ridge regression, I think, was 1970, and Lasso regression was 1980.
19. Oh, that was pretty recent then. Okay.
Yeah, yeah, these are more recent stuff.
Okay, got it.
These are not very old. Okay. And let me share my
Oh,
screen.
sorry. Yes, let me
Yeah.
allow this. Go ahead.
And then I wanted to show you a plot. So this is from the book of Hesti and Tipsy, which I follow basically for machine learning. And Tipsy is the guy who discovered the ridge regression part. Okay. So this is so what he did was he had some data sets. We're not going into the details. So all the names you see on the right side, these are the name of his regressors.
Okay.
Okay. And the x-axis is plotting something called S, which is basically the t scaled by the this quantity for so basically we discuss like so we look at this quantity and how much it is for these squares, and then if my t is higher than that, then it won't be touched, but if it's lower than that, then it will be strict.
Yes.
So we are looking at that ratio, and then the ratio goes from 0 to 1. So above 1, things won't change anymore.
Can you describe which ratio again? Can you say that slower maybe?
Yeah. So the ratio is t divided by sum of absolute value of the betas.
Oh, okay. Okay.
And those betas are coming from the the least
Yes.
squares.
Yes, got
Okay.
it.
So his point was that beyond s equal to 1, my coefficients will be keeping same. And then he has plotted how the coefficients are changing.
Yes, because t cannot be greater than,
Yes.
so it won't go
So
greater.
you can see that as s equals 1, all the coefficients are non-zero, but all of them fall to 0 after certain point. Like
True.
if you keep going from right to left, all of them go to 0 after some point.
True.
And different one of them goes to 0 at different points. Like not that all of them goes to 0 together.
So I'm thinking, can I guess maybe? Can I guess
Uh,
something? I'm
yeah.
guessing that you want to find like a shrinkage factor that's optimal, maybe somewhere around like zero point 0.6, where like there, I guess there is a zero, the Gleason or the LCP goes to zero there. So so you don't,
Yes, Matt, that may be a good choice. Like he's not commenting on which one is the best choice and all, but the idea is that if you choose some value of s here, that is automatically doing some variable selection for you because some coefficients are set to 0. So those variables are rejected.
yes, exactly.
Make sense?
Yes, exactly.
So the thing we're discussing about how to do the feature selection, Lasso does automatically to some extent.
Oh, cool.
So
Okay.
that's what Lasso is very good for.
Okay, got it.
And here, like we have an example of some 8, 10 regressors. I think if you in practice you can have hundreds of regressors, then Lasso will do it even better.
Got it. Okay.
Okay, so this is something Lasso is very good.
Very cool.
Okay. So you choose a value of s, and then like the choice he suggested is he given you one example, the red line, where basically only 3 coefficients are non-zero.
Yes.
So right at that point, 2 of the coefficients start becoming positive. So he's stopping just before
Oh,
that.
that's what oh, duh. Yeah. Okay.
That's where the line we chose.
Oh, duh. Okay.
Okay. Now, ridge regression, this thing doesn't happen. Ridge regression, all of the coefficients goes to 0 in slightly different rates, but all of them will be non-zero at every point. So ridge doesn't do variable selection in that sense,
Yes.
but Lasso does.
Lasso, well, that takes into account then. Okay.
Okay. And there is a very beautiful geometric interpretation of that, which
Whoa.
also this picture is from his book, to understand why that is happening.
So you
Okay.
have
So
one
the
regressive
left picture
person.
is Lasso and right picture is Lee's. So let me explain what is happening here. So he has chosen an example with only 2 regressors, beta 1 and beta 2. So every point in this picture is corresponding to 1 fit of beta 1 and beta 2. And this beta hat point in both cases are the least square estimate.
Yes.
Okay. And then you see some circle and the square kind of thing. That
Yes.
is basically representing the penalty coming from the ridge or lasso.
Yes.
Okay. So what we are doing is starting from the beta hat least square estimate, we are drawing some contours and trying to see what is best choice in terms of both the penalty term and how far you are going from the best least square estimate. So this is kind of a trade-off that is happening, the bias variance trade-off.
Yes.
So this is like a similar trade-off, but in the penalty terms, not in terms of bias variance terms.
Got it. Okay.
And in case of ridge regression, because the penalty contours are pointy, because like the square or rectangle will have pointed ends, there is a high chance that the agreement will happen at one of the corners. So the square in this case has four corners, right?
I was gonna ask though, maybe can we back step once? Why is like intuitively, why is the lasso more of like a sharp shape and then the
Oh, yeah. So let me explain that. So we discussed this dual thing of lasso, right? This sum of beta is less equal to t.
right,
So now imagine p is 2. Then this is basically some absolute value of beta 1 plus absolute value of beta 2 less equal to some t.
right.
And that is like equation in two variables.
Yes,
And if you plot that, you get this diamond thing, diamond or square.
makes sense.
So that's like a geometric thing.
Got it.
And similarly for the ridge regression, we have sum of squares of beta is, right? So if you put that sum of squares equal constant, that's the equation of a circle. Because beta 1 square plus beta 2 square equals some constant. So that's
Cool.
like a circle.
Yeah,
Okay.
that is cool. Yeah.
So that's where these pictures are from.
Oh yeah, you
So
can just see the two equations down there.
yes,
And
yes,
then
given the
that's a line, that's a circle. Okay, that makes sense.
okay.
Yeah.
And his point is that for ridge regression, because it is meeting of a circle with a ellipse kind of thing, then it will happen somewhere on the boundary of these two. But for the lasso, because the square itself is pointy, there is a good chance the agreement will happen in one of the corners. And then you do that way. Basically, in this case, the beta 1 will be 0 if you end up agreeing there.
Ah, super cool. Okay.
Okay. So that's like the geometry he gave in his example.
Hold on one second. Okay. So, but then on the ridge regression side,
Yeah.
it isn't taking that into account. So it does have some value of beta 1 there
Yeah.
then.
It can be small or large, but it will be non-zero because it's a circle. So there is very little chance of hitting exactly at the northmost point
Yes, 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 yes.
because squares are pointy. And if you increase the number of variables, it will be even more pointy. It will be a cube kind of thing. So a lot more vertices.
Yes.
So there is a more chance of hitting at one of the corner points.
Got it.
So this is the intuitive explanation of what is happening there.
Got it. When you're doing the modeling, then Sujay, do you start with like do you always start with linear and then build up and then say, oh, hey, we should check ridge, or do you start like how do you know between linear
Uh,
ridge and lasso where to
yeah,
start?
yeah. So in practice, what I would do is, so there are two concerns. One is the stability, which we discussed this condition number thing. Mm, yeah. So this condition number is ratio of the largest to smallest singular value.
Right,
So this is basically a good proxy for how stable your linear regression would be if you fit it.
right.
And second is variable selection. So general thumb rule is condition number below 30 is benign.
Condition number below 30 will be, sorry,
Like it's good. You
it's
don't have to worry about it.
you don't have to worry about it.
Then
Okay.
you don't basically go for ridge or lasso.
Yes. Yeah,
If
because
it's higher than that, then you go for ridge or lasso. And then in ridge regression, the advantage people say is that you get the variable selection for free in lasso of as opposed to ridge.
that makes sense.
So that's one advantage people go for. But lasso has some other advantages like the algebra is easier to understand and you have expressions for variance and all easy.
Got it.
Like I could get a formula for MSE in lasso in ridge easily. Lasso doesn't have as good a formula.
Got it.
And Lasso, we didn't even discuss like how to do the minimization. So there are some standard packages in Python or other programming languages which will do it for you.
I'm
And this is how they solve it.
okay.
Okay. But like it's a kind of a black box for you. You
Oh,
don't get to see how it works.
got it.
For each we have formula on our own.
Got it. Okay. Anything else that I would need to know for linear, ridge, and lassos?
Uh, I just want to discuss one quick example of something. I'll just drag my screen from Wikipedia.
I'm just
Let me
opening.
know if you can see it.